Okay, so for the self-practice tutorial 6 self-practice question 5, you're given this circuit diagram here and you're asked to find the voltage drop across R1, which is this resistor here. Voltage drop across R1, VR1, and VR2. VR2 is this. And the total current IT is given here from the supply source, voltage source, and current IR5. IR5 is here. Okay, current going through R5. So let's look at the first one, part A. So part A, now you look at the circuit diagram here. R1 and R2, they are in R1 and R4 are in series. Okay, and this part here is in parallel to this. Okay, the two of them, R1 plus R4, they are in parallel with this voltage source. Okay, they are in parallel with this voltage source. So the voltage drop across R1 plus R4 is equal to Vs. Okay, it's equal to Vs. So from here, because you know the voltage drop across this point, you can apply VDR. So for part A, you apply voltage divider rule. Okay, so VR1 equals to R1 divided by R1 plus R4 times Vs. Okay, so from here substitute the values. 20 ohm divided by 20 plus 40 times 30 volt. That gives you 10 volt. Okay, so that's part A. Next we look at part B to find VR2. Okay, VR2 is here. VR2 is here. So on the right side, you know there's this part here, a parallel circuit. So R3 in parallel with R5. This part here is in series with R2 and R6. Okay, so you have R2 in series with R3 in parallel with R5, and this in parallel with R6. So this part here, this part here, this part here on the right hand side is R3 in parallel with R5. So if you work out this, that will give you R3 30 ohm in parallel with 60 ohm times 30 divided by 60 plus 30. Okay, so that is the parallel circuit. So you work out the results. So in series with this, so again you can apply voltage divider rule. Okay, so by apply voltage divider rule or by VDR, VR2 is equals to R2 multiplied by Vs divided by R2 plus, we say R3 parallel with R5 plus R6. This is the whole thing here. Okay, the whole thing here. I'm going to use a red pen. The whole thing. The whole thing. This part here. The whole thing. Okay. It's this. Okay, in series. So with that, then you substitute the value. R2 is 30 ohm multiply by 30 volt divide by R2, which is 30 ohm, plus, so you have 60 in parallel with 30 plus 50 ohm. Okay, so you do your calculation. It's 30 times 30 divided by, so if you want to have more intermediate steps, plus 20 plus 50. So remember your volt, this is 30, that will give you 9 volt. Okay. You want to break down some more, you can have one more step before the 9 volt is fine. Okay, so that is 9 volt for VR2. Next, we look at part C. For part C, you are asked to find IT. So IT is this, okay, the current coming out from the voltage source. So you know the current come out from voltage source will go to the left, become IR1, right? And then on the right, IR2. So remember KCL says that the summation of current, sum of current entering the node is equal to the sum of current leaving the node. Okay, leaving the same junction. So you have IR1 plus IR2. Okay, IR1 plus IR2 is equal to IT. So here IR1 is equals to BR1 divided by R1. IR2 is BR2 divided by R2. Always try to make use of whatever values you have computed earlier. See whether you can apply them or not. If you can, use them directly. Okay, don't need to recompute. So VR1 is, where's VR1? 10 volts. So 10 divided by 20 plus 9 over 30. That will give you M. So that gives you 0.5 plus 0.3 equal to 0.8 M. Okay, 0.8 M. That's part C. So part D, to find the current IR5. IR5 is here. So again, from IR2, it will split to here, IR3 and IR5. So with that, you know you can apply CDR. CDR is used for parallel circuit, right, to find the current in the individual loop. So IR5 is then equal to, apply CDR, remember for two parallel resistor, for IR5 will be R3 divided by R3 plus R5 times IR1. This is IR2. Okay, then that will give you 60 divided by 60 plus 30 times 0.3 M. That will give you 0.2 M. You can always check whether your answer is correct. If let's say IR5, due to some calculation error, then if you notice IR5, how come it's more than my IR1? Then something is wrong with your calculation. You go and check. Okay, so remember current entering the node is equal to the total current leaving the node. Okay, I in, I out, I out. So if you've forgotten, please recap. Okay, recap what we have done in the summary lecture and also the tutorial questions. So that concludes question 5. Check your answers.